Hello CS11, this is lecture 24 and today we'll be looking through these topics. So to motivate what all of these words are, let's first go through this problem over here. So basically what you have is a bunch of data. I guess this is one of the closest. We'll be looking at yung actual applications ng doing all of this stuff in CS11. So let's say you have data and you want to represent that data in your code. So what I mean by data is something like this. So this is a bunch of data about yung mga cities in Metro Manila. So how do you represent all of this in your Python program over here? So let's look at a bunch of different ways in which we can do that. So the first simplest way is, well, this is a table and we already know that a table or a grid is a sequence of sequences. So what we can do first is we can represent this with a bunch of lists. So what you see here is exactly that. You have for each column over here, each column, it corresponds to one of these lists over here. So this does encode all of the data over here. So for example, all of the stuff for Quezon City is encoded in the first entry of each of the lists over here. So the question is this a good way to represent our data? So there are several issues that you will run into if you try to represent your data like this. And the main one is that since these are parallel lists, you will have to maintain them simultaneously. So if I wanted to add a new row over here in this table, I would have to add an entry to each of the lists over here. And since there are many lists, there are 6 lists over here, that can get pretty hard if you're not careful enough. So one additional issue is if you want to rearrange those lists, then rearranging one list will force you to rearrange all of the other lists. So let's say you want to arrange them by increasing barangay count. So you want to sort this list in increasing order. But if you do that, you would also have to sort all of the other lists. And since these are decoupled from each other, if this 23 was to go first, you would have to explicitly make all of these other entries over here go first, which is pretty complicated. So yeah, that's another issue. So because of that, it would be a better idea to actually group all of your related data together. So for example, yung first entries, all of the entries, first entries here, you want to somehow group all of them into one thing. So how do we do that? Well, the simplest way is to group all of those related data into a tuple. So here you have a list, but each of the tuples in this list represents a row in your table. So this is a tuple for Quezon City's data, and so on and so forth. So now the related data is grouped together. So if you want to sort now by barangay count, you can easily do that. You can do that using sort and giving it a key. We went over this idea in one of the previous lectures. So if you give it a function for which to sort it by, then you can easily sort this list over here using one of the entries in each, or using one of the, I guess, attributes or columns for each entry over here. Okay, so because we can now do this actually now gives us another problem. So what now? The problem now that we have to deal with is if we can sort them like this, we now have to remember what each of these entries actually represents. So, well, these first entries over here, these are pretty obvious, they're just city names. But what about all of these other numbers over here? Well, you could just look at the original table and maybe put a comment over here. But as you get more columns, you would have to update that comment and you would have to add more stuff over here. So how do we get around that? Well, one way is if we wanted to access one of the entries in this list, we could just do destructuring. And during the destructuring, we could just write it out like this. So we have an explicit variable name for each of the columns over here. So now that we have a name for each of the columns for that entry, we can now easily see which one refers to which. So this is still a problem actually. Now the problem with this is, well, since we're going to destructure this entry, we now have to remember how many fields that tuple actually contains. So this entry has 1, 2, 3, 4, 5, 6. Yeah, 6 entries or columns. And aside from that, the harder thing to remember is their order. So you would have to remember that the first entry is the city name, the next entry is the PSGC, then so on and so forth. So this is very easy to mess up. If you wrote it like this instead, if you accidentally swapped two of the entries over here, then you would get the wrong data now. So since both population and households are integers over here, Python wouldn't complain. You're just assigning values to variables. So this will also pass type checking, again, since they're both integers. But now you have the wrong data. So that's a bad thing. So how do we fix this issue? Well, if we really want to associate names to each of the parts over here in this tuple, then what we can do next is to put that in a dictionary. So in a dictionary, we now have keys that correspond to what the columns actually mean and their corresponding values over here. So now we know that Quezon City is the name, and these numbers refer to these columns over here. So using a dictionary, we can now also store that information. So is this now our ideal solution? Well, note that since these are dictionaries, yung order of the keys now doesn't matter. So even if you put one of the keys before the other one, let's say you swap these two lines, this will still represent the correct data since you know which value corresponds to which key. Okay, so the issue with this now is, well, since you're typing out yung key names for each and every single one of the entries here, so you have name, PSGC, population, all 6 of these keys for the first entry, you have the same 6 keys for the next entry, then so on and so forth. By writing out all of these keys explicitly, that's the part that becomes error prone. So here, if you accidentally write it like this household and this barangay, these are missing the letter S at the end. So these now represent different keys from the entries a while ago. So if you try to access this dictionary via the key households, you're going to get a key error now if you accidentally write the wrong key names. Okay, and in addition to that, you might also forget to add some of these keys. So here, there's only 5 out of the 6. Python still won't complain since, well, it doesn't really expect anything out of this dictionary anyway. You can't enforce yet that this dictionary has to have this key over here. So there, if you forget to add some keys, then you can have incomplete data like this. Okay, so how do we reconcile all of this? So what we want is, again, our first problem was we want the data to be grouped together. Tuples, or having parallel lists, couldn't do this for us, which is why we use tuples instead. Aside from that, we want to access the fields by name. So we couldn't do this with tuples, which is why we use dictionaries. And finally, we want each of the dictionaries to have a complete set of keys. So dictionaries can't do this for us since they don't enforce internally what keys they're supposed to have. So what can we do about that? What's the next step after using dictionaries? So the next step here now is we want to essentially make a new kind of object. So that object now has a certain set of fields that we can access by name, and each of those fields corresponds to a certain value. And those values are, of course, related to each other. So how do we do that? So let's go to a simpler example first. From city data, let's move on to a point. So a point is basically something that has an x coordinate and a y coordinate. So if we want to have functions that involve that point, some functions that we could use involve or include, let's say, getting yung distance of the point from the origin. If we want to rotate that point, we could have a function for that. And if we want to reflect that point across another point, then we could have a function like this. We don't know how these functions are implemented yet, but those are functions we would ideally want to have for this new data type over here. So how do you do that? So one solution to this is to use what we call named tuples. So Python has this function over here that basically makes a new type. So we already have, let's go here. So we already know from the very beginning, integers, strings, tuples, other sequences. So now what we're going to do is we're going to make a new type using this function over here. It's our own type, separate from all of the types that we've seen so far. Okay. So this new type is essentially going to act like a tuple, except yung attributes niya have names. So it's like a dictionary. It's a bunch of related stuff where each of those entries has an associated name. And this is how you do that. So let's have from collections import name tuple, and if you have that, you can make your new type by specifying the name of that type, then using that function like this. So this is the name as a string. Then these are the attributes you expect that thing to have. So you expect a point to have two attributes that have names x and y. So how do you use this new type over here? Well, one way is to do it like this. So here you have a point where you use the type point, then you give it the numbers 3 and 5. So this is now a point where the x corresponds to 3, the value 3, and yung y attribute corresponds to the value 5. So now you made an instance of your new type. Just like how 1 is an instance of int, 1 is an int, this point is an instance of this point type over here. Okay? So you can also write it like this. You can explicitly write out yung names ng fields. So if I have, this is x is 3 and y is 5, that will give me the same point. If the attributes are explicitly named, you can also swap their order. So this will still refer to the same point. Okay? So if you check yung type of this thing, you'll see that this is indeed, this value has a type of point. So now we've made a new type that has this attribute x and this attribute y. So if you want to check the type of something, again, you would usually want to use isInstance instead of using type. So do isInstance, then your value, then your class. Don't do something like type of point is equal to point or something, since this might give you unexpected results. Okay? Alright. So now, yung functions that we wanted a while ago, the functions here, we could now create our own functions that take in points, and they will use those points like this. So if you want to rotate this point counterclockwise by 90 degrees, then you would result in this point. So for example, if you want to rotate the point x is 3 and y is 0, so this is just 3 steps to the right on your x-axis. If you rotate that counterclockwise by 90 degrees, you would end up with 0 then 3. So that's essentially what's happening here. This is clockwise. So clockwise will turn it to 0, negative 3. So here it's 0, then negative 3. Okay? So that's what this function does. For the absolute value function, you can have this expression over here. Okay, so if you notice here, the way to access yung attributes ng point is by using dot, then the name of the attribute. So if we have our point from a while ago, and we do point.x or point.y, that will give us the corresponding values of those attributes over here. Okay? So if you use those functions, just like how you would use any other function, you will get these results that you expect. Okay? So if we go back to the city example, instead of using a dictionary, we can now have a named tuple. So if we use a named tuple, the name is city, then these are the fields that it should have. So now each of those cities is now defined like this. So a city which has these fields over here. So note that again, the order doesn't matter. And if you make a typo, or if you miss a field, then Python will raise an error. So let's demonstrate this using the point type. If I don't write out the value of y, I will get a type error over here. So here it's saying that it expects a corresponding value for y, but we didn't specify one here. So now your attributes have to be complete. What else? So if you accidentally mistype one of the attributes, so xx is equal to 3, y is equal to 5, this will also give you a type error. So you got an argument xx, it was expecting x instant. Okay, so now we've prevented yung problems that we encountered when we were using dictionaries. So that's mainly what named tuples are for. Okay, so what did we just do here? We've essentially, here we grouped up a bunch of related information into a single data type. So essentially, what we've made is what we call a compound data type. So we basically collected several different related values together in order to form our own data type. Okay, so if you want to use this term across several programming languages, or any programming language in general, the term that we usually use is a record. So this here is a record with these fields over here. Okay, so yung name tuple, again, if you think about it, it's a function that returns a type. So if you think about that, what that means is, since it's a function that can return a type, aside from functions being values, yung types themselves are also values. So if you take an integer and you get its type, you'll get integer. But if you get the type of integer, so the type of this type, you'll get type. So the type of integer is type. Okay, So also, this thing over here, from this line, we see that this is actually its own type. So if you try to go further, what is the type of type? Well, type is a type of all of the other types that we've seen so far. So if we get the type of type, what we expect here is, well, it's a type. Since, yeah, that is what it is. It is a type of these other types over here. Okay, that might be a bit confusing, so if you want, think about it for a bit. Why this returns this? But yeah, the point is types are also values. Okay, so yung name tuples, these are actually yung old way. So back in the day, he used name tuples. Yung new way is via this thing called data classes. So when we say data classes, they will look something like this. Okay, so there's a bunch of stuff going on here. So we have this import, we have this keyword class, and we have a decorator over here at data class. So what are these type annotations, and well, what is this class thing? So we'll go over this in a bit. The point is, this is essentially equivalent to yung point example natin a while ago. Okay, so this is how you make your new kind of type in Python. And if you want to use that type, it's pretty much the same thing. You instantiate an instance like this, and you access the field values like this. Okay? So aside from that, since this is a type, you can also use it for type annotations. So if this is a point that has, or if this is a point, then yung type niya is, well, point. So this type annotation will type check. Okay? So yung previous example with the cities now becomes something like this. So we have class city, these are the field names, and these are their corresponding types. Okay? And the way you make instances of cities is pretty much the same. Okay? So why do we have data classes instead of yung name tuple a while ago? What's the advantage? Well, the main thing is that we can now have what we call bound functions. So when you say bound functions, what that means is, if this is the point class from a while ago, or data class, we can have, or we can make an additional function over here that is exclusive to this data class over here. So we have this class has a function here that instances of that data class can use. So if we instantiate a point like this, we can do point, then dot, rotate clockwise 90, and it will behave like this. So instead of making a separate function, then passing in a point, we can now have the instance of the point, then dot, yung function, then that will give us the result that we want, using this function over here. Okay, so including the other examples from the previous slide, we have these functions as well for the transform and reflection functions. So here we now have 3 different functions that are associated with this data class over here. Okay, and the way you use them is, again, you make a point, then you do dot, the function name, then that will give you the result that you expect over here. Okay, so whenever you're using this function here, yung first argument that gets passed in to this function is this thing itself. If you notice here, there's a bunch of self that are scattered over here. These refer to the instance that is calling this function. So for example here, in this dot rotate clockwise, yung self ng rotate clockwise is referring to this point over here, which is why we have self.y and self.x, which refer to this and this over here. Okay, so self refers to the instance that is using that function. Okay, so this works like any other function. You can also have keyword arguments, periodics, and other stuff that you want. Okay, so the first argument to functions inside a data class usually have the name self so that you can refer to the instance that is using that function. Okay, so the fancy name for these functions inside data classes, these are what we call data class methods. So this is the transform method of yung point data class. Okay, so yung data class instances, if you make a data class like this, these instances are mutable. So remember, mutable means you can change that instance. So if you want to set x to -3 instead, you can do it like this. So this dot x is equal to 3. This is just like variable reassignment. If you do that, it will change the point to this. So nothing too fancy over here. So because they are mutable, remember that you cannot use mutable objects inside sets or dictionaries. Okay, since if you can use mutable stuff in sets or dictionaries, then mutating those things might affect the stuff inside that set or that dictionary. So there, you cannot add mutable things to these collections. So what if you really wanted to? You wanted to have a data class as a key in a dictionary. What would you do then? Well, for that, you just have to make the data class immutable. And the way you do that is using inside after yung data class decorator, you have frozen is equal to true. This is the same kind of frozen as frozen sets. If you explicitly write this down for your data class, then all instances of that data class will now be immutable. So if you try to mutate it like this, it's going to raise an error. Okay, so because this is now a immutable data type, then you can now use it for sets and dictionary keys. So you can write it like this. Okay, so in exchange for the instances being immutable, you can now use them in some of the collections like this. Okay, so another major advantage of using data classes over named tuples is that each of the attributes here can have default values. So we went over default values in functions in one of the previous lectures. Here we can also have default values for attributes. So here, yung default value ng x attribute and yung y attribute are both 0. So if you don't explicitly declare those attributes, they will default to 0 like this. Okay, so both the x and y coordinate of this point are going to be 0 since you didn't specify them here. Okay, so not all of the attributes have to be or have to have a default value. So you can also write it like this. And if you explicitly write out yung value for that field, then it will take that value. Otherwise, it will take the default value. So for this second item, yung quantity is 0. So that's this assertion over here. Okay, so you can also write it like this. You can explicitly write out yung attribute name, and you can also write out the attribute names for the other attributes here. So this is also fine. Okay, so one major thing to note here is, well, just like with functions, don't use mutable default values for data classes. Yung reason is pretty much the same as the one for functions. So this list will refer to the same list across all instances. Okay, so in order to actually, if you really wanted to, there are several ways to go about this. You can, in the data classes library, or part of the standard library, there's are certain fields or functions that you can use if you really want a list or some other mutable collection as a default value. So if you want, just search it up sa documentation. We won't cover it in this lecture over here. Okay, so here we have a bunch of classes. If you've noticed by now, yung names of these classes follow a certain format. So whenever you're writing a type name in Python, your own type, it has to be in what we call camel case. So camel case is all of the words start with a capital letter. So you can think of these as humps of a camel. So instead of functions where it's usually snake case, so define my function, then something. So for functions and variables, you usually use snake case. For data classes like this, you usually use camel case. So class, my class, then the stuff over here. Okay? So use camel case for classes like this. Okay, so yung built-in types are the exception to this. Usually yung built-in types are just, well, lowercase. Okay, so we know that data classes are also types. But is there actually a difference between these two things? Are data classes the same thing as types? That is something we'll go over in one of the later lectures. Okay, so how are data classes related to types? Okay, so the last thing we're going to go over for this lecture is the stuff we'll see in the next few slides. So in relation to lists and classes so far, let's look at this example here. So we know that, well, this list is definitely not equal to this list since lists are ordered. So if we have, let's try 1, 2 is 2, 1, this will give us false. So they are not the same list. What about this? 2, 1 is 1, 2. The elements are still in the wrong order, so this is also false. How about this? Is this empty list equal to this? It is, since, well, they're both empty lists. But what about this over here? Is this? So now we get false. So if we use the is keyword instead of double equals on two empty lists, we get a answer of false. So what is happening here? So remember that when we talked about yung environments for imperative programming, we said that there's a world of values. So all of those values are stored inside the computer's memory. So when we have two different objects, so let's say these two lists over here, they might be equal as structures. So let's say we have a 1, 2 and another 1, 2. These might be the same list with the same values, but their locations in memory could be different. So the location of this could be different from the location of this. Okay? So in terms of the difference between two equal objects, we have different terms that we use to refer to that difference. So first is what we call structural equality. So if they're the same thing, or if they have the same elements over here, we say that they are structurally equivalent. So structurally, they have the same elements over here. So if we compare them using equals, then it returns true. On the other hand, we also have what we call referential equality. So referential equality checks if these lists are in the same location in memory. So if we have 1, 2 is 1, 2, this is false since both of these lists are in different locations in memory. If we did something like A is 1, 2, oops, A is 1, 2. Then we have A is A. This would be true since these are referring to the same list in memory. Otherwise, if we explicitly make two different lists here, then that's when we get referentially different lists. So basically, double equals checks whether two things are structurally equal, and is checks if they're referentially equal. Okay, so try to think about these questions here. So if two things are structurally equal, then are they referentially equal? As we've seen from the previous examples, this is actually false. So what about the opposite? If they are referentially equal, are they structurally equal? So well, this is true, and most of the time. Yung special cases here are something that you don't have to worry about yet in CS11. But yeah, most of the time, if you have this, then if they are referentially equal, then yeah, they are structurally equal. Okay, so for data classes, let's go back to data classes. Yung double equals, this uses structural equality. Okay, and this double equals, it's also done recursively on the attributes. So if you're comparing two data classes, let's say point x is 3, y is 5, and point y is 5, x is 3, if we compare these 2 points over here, then they have the same structure, they have the same fields, and those fields have the same value. So they are structurally equal. Okay, for simple types like integer, boolean, and so on, yung double equals actually uses a slightly different kind of equality, and that's what we call value equality. So essentially, whenever you're checking if 1 is equal to 1 or 1 is 1, that will always return true even if you write it like this. Okay, so for data classes, this is structural equality, and it's recursive. Same thing for containers, so sets, dictionaries, lists, and so on. So we have, if we have these examples over here, this is not referentially equal to this list, but if we nest these lists like this, these have the same elements as this, so they are structurally equal. But of course, you're building up different lists in memory, so they are not referentially equal. Okay, so how do we actually get yung identity that is used if we are checking for referential equality? For that, we have yung ID function. So if we have ID or help ID, so this basically returns yung identity. So if we have ID of 1, 2, this big number over here, this is basically a location in your computer's memory. You can think of it as a really long address. If we have a different list, this is in a different location in memory. So this is somewhere else compared to this. So if we have A is this list and B is this list, if we get the IDs of A and B, we'll see that they are in different locations in memory, which is why A is B gives us false. Okay? So this statement holds over here. So for yung default implementation, which is called CPython, this ID function returns yung address in memory. So it's just like a house address except for your computer's values. Okay? So try not to use this that much. It's not something that you'll really need. Usually the closest that you'll get is using this is instead. Okay? So there are several examples over here. If we have a tuple, 1, 2, if we have list x is list x, will these give us the same thing? So this is false. Tuple x is tuple x. This is true. If we have string x is string x, this is false, and if we have int 12, is int 12, this is now true. So why is all of this happening? So for some types, when we create a new value, what we actually do, or what Python actually does, is it uses a value that already exists. So for this case over here, these both make the number 12. What Python actually does is, for small integers like 12 for example, it treats all instances of 12 as the same thing. So if you have id of 12, or a is 12, b is 12, and if we get the IDs of each of them, ID of A, ID of B, they are the same ID. So Python uses the same value in memory for small values. So this idea is what we call interning those values. And as you can probably tell, doing this makes it so that you use up less memory whenever you're using integers like this. So it's more efficient. Okay, so this is mostly an implementation detail of Python itself. It's not something that you really have to know deeply in CS11. But yeah, it's good to know that this is how Python treats small values like this. Okay, the main downside of this idea, interning, is that it's pretty unpredictable to use the is comparison. So because of that, if you have a immutable type, so if you have a tuple or a int, try not to use is. So if you remember a while ago, we had 12 is 12. It gave us a warning over here. So if you're using a immutable type, just use double equals instead of is. There are a few exceptions here, but for the most part, what you'll usually want to use is double equals instead of is. Okay, so for most immutable types, use the double equals for comparison instead. Okay, this enum thing that you see here, this is something that we'll go over in a lecture soon. Okay, so yeah, as you can see, we have a warning if we try to use is for small immutable types. Okay, so that is data classes and value comparison in Python. So again, all of this stuff is very useful, especially if you want to represent some sort of organized data. So our very first example here was a bunch of data from a table. You can now probably imagine if we have a table of lots of data, all of that can usually just be represented using Python data classes. So that's one of the things that makes programming languages like Python very powerful for processing large amounts of data. Okay, so yeah, that's going to be it for this lecture. In the later lectures, we'll look at other nice advanced Python features like yung enums that we mentioned briefly at the end. But yeah, for now, we'll end here. Thank you for watching.